math here. We're learning graphing using intercepts.
Very good. Okay, intercepts. We're going to talk about the two types of intercepts. We've learned one of them already, which is a Y-intercept. And we're in slope Y-intercept form. That is our y equals mx plus b. Our b essentially represents our y-intercept. Okay, we've learned that already. A y-intercept is when our x value is 0. So in order to find a y-intercept, if we can't quite remember where it would be in an equation, we can always set x equal to 0 and solve for y. It will tell us exactly what our coordinate is. With that in mind, an x-intercept is essentially the opposite. An x-intercept is when our y value is 0, and we can set our y value to 0 and solve for x. So on a graph, we'll do a rough sketch over here. Y-intercepts occur on the y-axis, okay, when we cross there. And an x-intercept occurs when we cross the x-axis. That's what these two are talking about. And if you notice, when we're on the y-axis, our x value is 0. And we're on the x-axis, our y value is 0. Okay. So we'll take this here. We're going to find both an x and a y-intercept of our first equation. Now, what form is this one in? Standard. That's right. This is in standard form. So the first thing I would like to find is a y-intercept. So to find a y, let me say just a y-inter, what do I have to set equal to 0? That's right. We set it right up here. I need my x value to be equal to 0. So therefore, x must equal 0. So this value here, we're going to replace with 0. We get 3 multiplied by 0 minus 5y plus 15 is equal to 0. What is 3 times 0?
0.
All right, so this is what we're left with now. Is this our y-intercept, this equation here? What do I have to do with it? I can solve for this, our y. And what we're actually doing here is we're finding a coordinate. When x is 0, what is the y value? That's what we're doing. We're finding our y coordinate when we plug in x for 0. So I have to set it equal to y now. So the next step here would be to move our 15 to the other side. What would it become? That's right, it would become negative 15. So we then have negative 5y is equal to negative 15. That's right, because we're trying to isolate just y, and because it's negative 5 times y, to move the negative 5 over, we have to divide. So we'll be left with y is equal to, what is negative 15 divided?
3.
Positive 3, good. So, our positive 3. So this is a coordinate, 0 and 3. In fact, it's our y-intercept. So if I were to quickly bring up a graph, let's see if I can find one. By one's perfect. Okay, so if we bring up our graph here, our y-intercept is at positive 3. So we know we cross here. That's one of our points. The other point we want to figure out is our x-intercept. So I'll do it below the graph, the exact same equation. Copy it. Okay. So exact same equation, but in this one, to find an x-intercept, what is it we need to do? Set what equal to 0? That's right. Our y value we need to set equal to 0. So the y here, we're going to replace with a value of 0. So it becomes 3x minus 5 times 0 plus 15 equals 0. What is negative 5 times 0? So I have 3x plus 15 is equal to 0. And what do we have to do? What's the goal? Got to isolate for our x. So we move 15 over. Great. We get 3x equals negative 15. And then what do we do here? Perfect. Good. So x is equal to negative 5. So what that means, if I were to graph this, okay, because remember this coordinate here was at 0 and 3. Our next coordinate is when y is 0 and x is negative 5. So that's over here. This is negative 5 and 0. These are two intercepts. With those two intercepts, we can graph a line. You only need 2 points to graph a line. Oh, I didn't graph that well. I'll move it a little. But here's our line. We've now graphed our linear equation. It goes through those two intercepts. Okay? So we've represented the equation in standard form, and we found both the intercepts. That was from standard form. What if we were in our slope y-intercept form? Well, how can I find my y-intercept very quickly? No, that's not our y-intercept. Remember, a y-intercept is when we set x equal to 0. Okay? So it becomes 0 and some y value we're trying to find. Okay? In slope y-intercept form, what is the b value? What does that stand for? The y-intercept. It is 16. And we can prove it by plugging values in. We'll replace x with 0. So we get y is equal to 8 over 3 times 0 plus 16. Okay? What is 8 over 3 times 0? 0. So what is y equal to? 16. So that's why that's called y-intercept form. You can eliminate this value very, very easily. Okay? So that's why that is our y-intercept. Now, a little harder to find x-intercept. We take the exact same equation, y is equal to 8 over 3x plus 16. A x-intercept, did I use the wrong color up there? Oh, I did. Sorry. An x-intercept is when we set y equal to 0. So we're solving for x, and y is equal to 0. So this value we replace with 0. So 0 is equal to 8 over 3x plus 16. I'll then have to isolate for just x. So what's the first step here? Move what over? Yeah. What does it become? Negative. So what's 0? Yes, very good. Subtract 16. So it becomes negative 16 is equal to 8 over 3x. This is hard. We have a fraction here. I'm going to break this fraction into two parts, right? Remember, this could technically say 8x over 3, if I didn't look at it like that. How can I move the 3 first? That's right. Let's multiply both sides by 3. Or in other words, when we bring it over, it becomes multiplied by 3. Okay? So when we bring that 3 over on the right side, we're only left with 8x. And 3 times 16, anyone know? Very good. It's negative. Because it's positive times a negative, it's negative 48. Okay? And then how do I get the x by itself? What do I need to do? That's right. We need to divide by 8. What is 48 divided by 8? I don't think it's 8. Yeah. It's 8. 6. Negative 6. So, our intercept, or our x-intercept, Phil. Our x-intercept is negative 6 and 0. So, if we were to plot these 2 points on our graph, we have, what was our y-intercept? 16? Oh, 16 is a little high for our graph. So I'll just do a rough sketch. We had one value at 16, so way up here, which was at 0 and 16. And our other one was at negative 6 and 0. This would be our line. Now, we're not going to go through it, but I have a quick question for you. How could we find the slopes of these? Like, obviously, in our y-intercept, what is the slope? 8 over 3. Well, let's talk about our standard form very quickly. Our standard form. What's one way I could find the slope? Yeah, we could change it to slope y-intercept form, so set it equal to y. What's another way we could do it? Well, we have these 2 coordinates. What can I do with 2 coordinates? Yeah, we could find out the rise, which is 3, over the run, which is negative 5. Or actually, it's positive 5 and positive 3, right? We're going in that direction. So it's 3 over 5. Or we could have plugged it into the equation y2 minus y1 over x2 minus x1. All of these ways would work. Okay? So what you're learning is there's many, many different ways to manipulate an equation.